Hey everyone! In this video, we're going to be talking about how to find our absolute extrema. That is, how to find the absolute maximum values and the absolute minimum values. Now, one really important thing that we need to begin with is when we're looking for absolute maximums or absolute minimums, we need a function that is continuous on a closed interval. So in other words, what we're looking for are the largest possible values on a specific interval or the smallest possible values on a specific interval in the entire interval. If I compare that to local maximums or local minimums, those were just the largest or smallest in a small neighborhood. So that was a small open interval. But in this case, we're looking at a closed interval. So it's basically what are the largest and smallest values for the entirety of our function. So to begin with, I detailed a couple steps here that we can follow to allow us to find these absolute maximums or minimums. So I said, step one, locate all critical numbers in the open interval a to b. So those are all the points that are in between our two endpoints, and we want to find all the critical numbers within that. So critical numbers, these are going to be where our derivative is either 0, meaning we have a horizontal tangent line, or where our derivative is undefined. Step two, evaluate the function at each critical number and at the endpoints a and b. So either at the critical numbers or at the endpoints, that's where the maximum or minimum values are going to occur. So we want to test all of them. And step three, this is what I just said. The largest value is the absolute maximum and the smallest value is the absolute minimum. So now that we have the steps, let's take a look at a couple examples and just talk through this process. So my first example, I have the function f of x is equal to 2x cubed minus 3x squared minus 12x plus 8, and we're looking at the interval from -2 to 3. So the first thing, I do know that this is a continuous function because it's a polynomial. So it is continuous on this closed interval that we're given. So our little test here will work. The first thing I want to do is I want to find all the critical numbers for this function. So let's start by finding the derivative of f of x. So f prime of x. Here, this is a polynomial, so we can just use our power rule on each of the terms. So the derivative of 2x cubed, the 3 will come down out front. So that's going to be 3 times 2 is 6x squared. And then the 2 will come down. We'll have minus 6x to the first. The derivative of negative 12x is just negative 12. And the derivative of 8 is 0. So now what I'm looking for these critical numbers is where is this going to be equal to 0 or where is this undefined? Well, the first thing here, because it's a polynomial, there's nothing that's going to make this undefined. So we're just looking for when is this going to be equal to 0. So let's set this equal to 0 and solve for x to get our critical numbers. Right away, I see that we have a factor of 6 in all these coefficients, so we can divide that out. So that's going to give us x squared minus x, and if I divide out the 6 from here, we get minus 2. All right, so hopefully we can factor this. We're looking for two numbers that multiply to -2, add to -1. This is going to factor into x minus 2 and x plus 1. Taking both of these factors and setting them equal to 0, we can solve for x and find our critical numbers. So we end up with critical numbers at x is equal to 2 and x is equal to -1. Let's double check these. So our interval is from -2 to 3. Both of these numbers are within that interval. So we're going to want to test f of -2 for the endpoint. We'll want to test in the middle. We have f of -1. We have f of 2. Those were our two critical numbers. And we'll also want to test our last endpoint, f of 3. So now we're going to go back to the original function, and we can plug these in. I can do this algebraically. I can plug everything in and simplify and get my answers. Or I can use my calculator to help me out a little bit. So let's take a look at that. So on our calculator, I'm going to go to the y equals button to enter an equation. Let's type in our functions. We have 2x cubed minus 3x squared minus 12x and plus 8. So here's our function. I could try and graph this right away, but I think I want to do a little bit of setup first so we can take a look at it more accurately. So the main piece though is now if I hit second table, so I hit the second button and then I hit the graph button, so I want table, it will bring up all my function values. So now we can just take a look at this, see what the y values are for each of our critical numbers and the endpoints. So let's see, at -2 we have 4, at -1 we have 15, so let me write those down. So at -2 we had 4, at -1 we had 15. I'll bring that back up. And at 2 we have -12, and at 3 we have -1. So here we have -12 and -1. So right away, just taking a look at this, we can identify what our maximum and our minimum value is going to be. So the overall largest value is 15. So this is going to be our maximum, our absolute maximum. And then our smallest value, the -12, this point is going to be our minimum. Now let's verify that just by taking a look at the graph of this function. So I want to set up my window so I know what I'm taking a look at here. So if I click on window, I'm going to set up my x's to surround the interval I'm looking at. So I want to go from -2 to 3. So I'm just going to go a little bit to the left of that and a little bit to the right of that. So I have this set at -3 to 4. So that covers the entire interval. And then I also know my maximum and my minimum right away. So let's go down to my y minimum. I want to make sure I get -12 in there. So I'm going to go a little bit lower than that. I'll go -13. And then my maximum is 15, so I'll go a little bit higher than that. So I'll do 16. And now if we take a look at our graph, we should see that we have our maximum and our minimum values. So at -1, here's the absolute maximum, and at +2, here's our absolute minimum. Now, this polynomial does continue on forever in both directions, but because we are restricting it to just specifically this interval, we can identify the absolute max and the absolute min. All right, let's try one more example, a little bit different. So here I have a rational function, g of x is equal to x plus 3 to the 2/3 power divided by x plus 1. And let's find the absolute max and absolute min on the interval from -4 to -2. So let's start the same way. Let's find our critical numbers first. So let's find the derivative. In this case, we are going to need to use the quotient rule to find the derivative. So I have the denominator times the derivative of the numerator. So that 2/3 power will come down. Then we have x plus 3. I subtract 1 from the exponent. That's going to be a -1/3 power. And I would have to use the chain rule here, but the derivative of the inside is just 1, so I'm not going to write that. And then we're going to subtract our numerator times the derivative of the denominator. And the derivative of the denominator is just 1 again. And then this is going to be all over our denominator squared. All right, now this is a pretty messy expression here. I have x plus 3 to the -1/3. I have x plus 3 to the 2/3 power. So I'm going to use a clever piece of multiplication to help me simplify this. So I'm going to multiply this fraction by 3 times x plus 3 to the 1/3 power. And if I multiply that to the numerator, I need to multiply that to the denominator as well. Now I'm picking this fraction out very specifically. The first, I want to pick out 3. I'm going to multiply by 3, so that will simplify this fraction I have in 2/3. And the second piece, the x plus 3 to the 1/3 power, when I distribute that to both of these terms, I have an x plus 3 base, so I just need to add these exponents together. And in both cases, this is going to simplify really nice. The negative 1/3 power plus this 1/3 will give me a power of 0, which simplifies really nice. And here, if I add on the 1/3 to this exponent, I'll have x plus 3 to the first power, which again will simplify very nicely for us. So let's rewrite some of this. So I still have my x plus 1. Distributing, the 3's will cancel out, so I still have the 2. And now multiplying x plus 3 to the negative 1/3 and x plus 3 to the positive 1/3, I will end up with x plus 3 to the 0 power, which will just simplify to 1. And then I'm going to subtract. Here I will have a 3. And now x plus 3 to the 2/3 times x plus 3 to the 1/3, I get x plus 3 to the first power. And then in the denominator, we're going to have 3, x plus 1 squared, and the x plus 3 to the 1/3 power. So now let's just simplify our numerator, and we should be able to identify our critical numbers. So this whole binomial is going to simplify to 1. So that's just going to be 2x plus 2. And then distributing the negative 3, we have negative 3x minus 9 all over this denominator. 3 times x plus 1 squared, x plus 3 to the 1/3. And to finish up simplifying our numerator, so 2x minus 3x, we have a negative x. 2 minus 9 is negative 7, all over our denominator. So now I think this is at a point where we are simplified enough where we can identify our critical numbers. We are looking for when the derivative is equal to 0 or when the derivative is undefined. So for it to be equal to 0, the numerator will have to equal 0. So if I take negative x minus 7, set that equal to 0, I'm going to end up with a critical number at x is equal to negative 7. In the denominator, any value of x that would make the denominator 0 is going to make this derivative undefined. So that's going to give me 1 at x is equal to negative 1 and x is equal to negative 3. Now let's take a look at these critical numbers a little bit. So the first thing, a critical number also has to be a part of the domain of the original function. Negative 1 is excluded from our domain, so this one is not a critical number, so I don't have to worry about that. The second thing, when I'm going to test these values for absolute maximums or absolute minimums, I just need the ones that are within this interval. Negative 7 is outside of that interval, so I don't need to test that critical number, although it is a critical number. So that just leaves the values that I want to test. I have f of negative 4, one of the endpoints, f of negative 3, the critical number we found within the interval, and f of negative 2, our other endpoint. So let's use our calculator again to help us out with this. So I'm going to go back to my y equals, and I'm going to type in my new equation here. So I have x plus 3, and I'm going to raise this to the 2/3 power. So 2 divided by 3. If I hit division, it'll type it in as a fraction for me. I'll hit the right arrow to get out of the exponent, and I'm going to divide, and I'm going to put my denominator in parentheses as well, x plus 1. All right, and then I hit second table, and it should give me my values here. So again, if I look at this, negative 1, it says error, so that tells me that that is not part of the domain. And now taking a look at the values we want to test, at negative 4, we have negative 0.3333, which that's going to be equivalent to 1/3. And then at negative 3, we have 0, so let me write those down. So at negative 4, we have negative 1/3. At negative 3, we have 0. And then the last one we were testing, at negative 2, we have a value of negative 1. So among these 3 points, the largest value is going to be our absolute max. 0 is the largest, so this point is going to be our absolute maximum. And then the smallest value, -1, this is going to be our absolute minimum. And again, we can just verify this by taking a look at the graph of this function. Again, I'm going to click on Window just to set it up so we can see our graph in full. So my interval is from -4 to -2. So I just want to make sure that I am a little bit on either side of that. So I'm going to go from -5 to -1. We know our maximum and minimum is at 0 and -1. Those are pretty close together, so I'm going to space it out a little bit. I'll go from -3 to +3 in the y direction. Now if I hit graph, hopefully we can see our function. So it's loading, it's thinking, but as we can see here, so our interval is from -2 to -4, so just this little region here. So at -3, it does touch the x-axis, so at 0, that's our absolute maximum for this interval. And then at -2, we have this y value of -1, and that's our absolute minimum on this interval.